Suppose we have a list of elements A, B, C, D, so on, and we have some element x, and we're trying to find this element x. So we're trying to find this element x within this list, and we write some code, and what this code does is it doesn't know where to find x, so it just randomly searches within the list and samples something and pulls it out of the list, so pops it from the list after sampling. So what's the best thing that can happen? Well, the very first thing we find might be x, and that's the best possible scenario we want to be in. We can be in. So if that's the case, we find x on the first try, then we're done. So that took one step. So we find x on the first try, we're done. That's one step, and that's the least possible amount of time it can take. This algorithm can take. Least amount of time this algorithm can take. So this is, since it's the least amount of time we can possibly finish our work in, we'll call this the best case runtime. And again, this best case runtime is simply the least amount of time our algorithm can finish in. Time possible that our algorithm can finish in. Now, what is the worst case? Because here we talked about the least possible amount of time that our algorithm can finish in. That's the best case. How do we find the worst case? Well, what if we don't find x until, okay, let's say x is guaranteed to be in the list. X is definite in the list. Okay, so we have a guarantee that x should be in the list. So what if we don't find x until the until the list only has one element left, or in other words, we find n minus 1, where n is the size of the list. We find n minus 1 items, not x, and then we finally find x. So if this is the case, this is the longest possible time our algorithm can take, right? So this is the worst possible scenario we want. It's the worst case. So we describe the worst case runtime as the greatest amount of time possible for our algorithm to finish in, right? So we have the best case, which describes the best possible scenario we can have and we finish very quickly, and the worst case, conversely, describes the greatest amount of time possible that our algorithm can finish in, and that's the worst scenario we want, right? We want our code to finish quickly, as quickly as possible, and we don't want the case where we have to let our code run for longer than maybe it might need to. So that's why the best case runtime is the one with the least amount of time that our algorithm finishes in, and the worst case is the greatest amount of time that it can finish in.